Okay guys, this is problem number 469. We're going to be finding how long it takes for the total pressure in the flask to rise to 1 atm. To start, we're going to set up our ice table, and for the initial it's going to be 600. They don't give us anything, so it's 0, 0. For our change, it's on the reactant side, so it's minus x. On the product side, it's plus x, plus x. Then just to get our equation, it's going to be 600 minus x, x plus x on the other side. And then for that, we're going to use that to get our total pressure. Okay. Now, with that, it's actually going to be the 600 minus x, and that's going to equal 760 or 1 atm. And that is going to be just to find x, of course, it's going to be 760 minus 600, and we're going to get 160. We're going to use that to find our pressure of SO2Cl2, and that's going to equal the equation for the first one, so it's 600 minus x, and of course we're going to plug our x in there, and that's going to be 440 millimeters of mercury. Okay, and then we're going to find our initial pressure of the same, and that's going to be just 600 because that's what they gave us initially. Okay, and then we're going to find our rate constant, and then that formula for that is K equals the log of 2 divided by its half-life. So the log of 2 is going to be divided by 8.75, and then from there, when we actually calculate that, that's going to equal 0.079217. And in case you're wondering where we got that 8.75, that's from our actual problem that they gave us. Okay, and then we're going to use first order reaction because, as it's stated in the problem, it's a first order. So the equation for that is log of pressure divided by the initial pressure equals the negative K times T. And now remember, we're finding T, okay? So that's the most important one. So we're going to actually start that out, and I'm going to go ahead and do that. And that's going to be the ln, and that's going to be the initial P. Remember, so we have our P, which is 440, divided by the, sorry, not the initial, but the P divided by the initial. And that's going to equal, remember, our negative K, okay, is actually going to come from here. So that's where we're going to actually get 0.079217 times T. And of course, just to get that by itself, we're going to go ahead and do the negative 0.079217. That's going to cancel there. And we're going to go ahead and divide it on this side as well, 0.079217. And when that comes out, our T is going to go ahead and actually equal the 3.92 hours. And that's how long it actually takes.